This is clock.
This is
1 and 0.
this is 1 and this is 0. This may be used for clock and this may be used for input.
Okay.
So first we are using suppose SR flip-flop. So in SR flip-flop, the SR flip-flop works on logic 0, right? This is see for S R.
Or it's all relief.
You will see the video. SR flip-flop reads, this is S and R. Come here, stand here. Stand on the piece. Stand. No, you don't stand. Logic 0 on R and logic 0 on S gives you set. And this gives you reset. And this is output 0. And here is logic 0 on S. It is set. Output 1. This is on S. Give me this wire. This is your for ground connection. Use any ground. Any ground. Ground.
Oh, ground.
Okay.
Ground. Any ground on the circuit. This is output.
Okay.
Use it. No problem. Come anyway. Come here. Okay, logic 0. Logic 0 to S point, the output should be set. So output is set.
Okay.
Don't need. For SR flip-flop only one wire. Logic 0 to S point, output is set. And logic 0 to R point, output is reset.
Oh.
Okay.
Bus this. And the Q, this is Q point. This is Q bar. Q bar is always opposite to Q. This is 0, so this will be 1. In this case, this is 1, so this is 0.
Okay.
This is your set and reset flip-flop. You can set and you can reset your flip-flop as per your requirement in the beginning. So this is just set reset flip-flop bus.
Okay.
If you apply logic 1, no change will be there in the output. So output will remain in the last state.
Okay.
And it will work like a memory. Because whatever state is there, it will be in that state until you change. If power off, then also, then also the state is same.
Change, yes.
No change. Now logic 1. Here again I will try it. Logic 0 to S point. Set this. Now I power off it. Now I will power on it. It is set. I apply logic 0 to R point, suppose it is reset. Now apply power off and power on. It is reset. So this is all about set reset flip-flop. Just use logic 0 and don't use logic 1. Logic 1 will not affect on the output. Next is your D-type flip-flop. So D-type flip-flop has Q bar output pins, D and clock input pins, and these two PR and C is clear. Not clock, it's clear. CLR. It's like S and R. So this part is like your SR flip-flop, and this part is in addition of the SR flip-flop you have data and clock. So you can set initially you can set or reset. So use logic 0 to suppose set apply here. Logic 0 apply here. It should set. Where is getting? Connect the output level. Connect logic 0 here. It will be set, and logic 0 here. It will be reset. Logic 0 here. Set, reset. So this is just for initial condition. So initially you want to start with reset, suppose. So I apply logic 0 here. It is reset to 0. Over.
Set to 1.
Just it is reset to 0.
Okay.
Now I want to apply my data D. D is your data. So my data is suppose 1 0 1 0 1.
Okay.
Clear? This is output. What output will come? I apply data and clock. Here clock and here data. A to A, B to B. Okay?
Okay.
Clock I apply up and down this way.
Yes.
This up and down means one clock to B. Now I apply, first bit is 1. I apply 1 and apply clock.
0.
It's already 1.
1.
So
Okay.
your new output is, this is new output is 1 after clock. Again I apply 0, apply logic 0 and apply next clock.
0.
يا اخي فهد تعال نتصور.
Yeah, it's 0 now.
كذا ما بدنا نوصل الكاميرا.
New bit, apply 1, apply clock, it is 1. Again new bit, apply 0, apply clock, is 0.
Okay.
Again apply 1, apply clock, it is 1. So after every clock you have your new bit available at the output.
Okay.
So this is data input, this is data input, this is data output, both are same but under control of the clock.
Yes.
So you can have output available but under the control of the clock. So this is the working of D flip-flop.
Okay.
And you can lock the D flip-flop anytime in 1 state or 0 state depending on your need, with the help of continue apply logic 0 to this point or this point. This is ground means logic 0. So this pin helps you to continue apply logic 0. I apply here suppose this.
Okay.
Set this logic 0 to S. Always set to logic 1. Now input has no effect on the output. Okay, this because flip-flop is lock at logic 1. Same way you can lock flip-flop at logic 0 like this. Now flip-flop is locked at logic 0, you cannot change the output irrespective of the input, the output is logic 0.
Okay.
This is the points available in D flip-flop. Okay? This is completed D flip-flop. Third is your tri-state buffer. So this is output, apply here output. A to A and B to B for tri-state. And use block select to see the lights.
Okay.
Then tri-state
Why did I
output
put that there?
to see the lights. Keep output enable 1 so that this buffer will work normally.
Okay.
Output enable 1, so this 1 will give you 1 output, and this 0 will give you 0 output.
Okay.
This 1 give you 1 output,
0.
input 0, output 0. Now if this output enable pin is 0, then no effect of the input on the output.
Never change.
No change, and the output is in high Z state.
Oh, how is it?
This is high Z state.
Okay.
And you have source and sink current. If it is 1, then apply 1, it will go to 1, and in that case the system is the tri-state buffer becomes a source of current. If output 1, tri-state buffer becomes the source of current. It can give current to next circuit.
Okay.
If the output is
Zero.
if it is 0,
You can't.
the
give-
tri-state buffer become sink of current. It can catch the current from other. It can drag the current from other source. So it becomes sink of current. So these are the points available in tri-state buffer. Okay. So this is the three important practical. And gate, NAND gate, OR gate, NOR gate, XOR gate, XNOR gate, you know, and NOT and buffer. Total 8 gates. So you have to draw 8 gates, diagram, their expression, their
The diagrams.
with diagram, with expression, and with truth table, and perform. What wow! You did already in first practical, first assignment. This is just 5 minutes thing. Okay, now you practice yourself. Thank you very much. This is Muhammad Sajid.